Hi, I'm Thomas Peterson, and this is my BuzzStream multi-region C and extra credit assignment. So here's my diagram. This is BuzzStream with regional edges. So a viewer's request carries an X-viewer region header standing in for the GeoIP. So the load balancer reads it, picks that region's pool, and we've got two edges in the west and then two in the east, and then consistent hashes inside the pool to pick a specific edge. So each edge has its own cache, and behind all four is a primary origin with a passive backup. So there are two routing decisions per request, which region, and then which edge inside of that. So we'll go to the first one. This is the same URL both times. The only difference is the region header here, as you can see the east and the west. The west viewer lands on edge west 1, the east viewer on edge S2. Different physical edges. Both are a miss because neither cache has it yet, so you just have to look at the cache key. It's not just the path, it's east and west prefixed, so those are two separate cache entries. And the bodies differ too, but the origin encodes per region. So the region isn't cosmetic, it just changes the content. Now, for this one, this actually repeats. West goes miss, then hit, hit. And critically, it's the same edge every time. So it's edge west 1. And that's cache locality, so consistent hashing sends the same object back to the edge that already has it. And 440 milliseconds down to 3. The east side does the same thing independently on edge east 2 right here. Neither region warned the other's cache, so they each paid for their own first copy. Now we're going to go to the load test, and that's where there's two requests. Here's their 300 split across both regions with realistic long tail traffic. Basically, 96% of it is hitting 5 popular titles, and both regions land above about a 90% hit rate, which is good. Every hot object stayed pinned to exactly one edge inside its region, so the locality holds under load, just not in a hand type demo. So the separation table shows the same object cached independently on both sides, one copy per region, which is the whole design goal, and thankfully nothing leaked across the pools. So this one in the whole region down, it decided to just kill the entire west region with both edges. So west viewer requests the same URL. They get a 200, not a 502. The X region decision says cross region fallback, and XCDN node shows an east edge answered. But if you look at the cache key, it still is west, and the east edge stored it under a west key and served west content. So the 4 seconds is the honest cost here. It's to connect timeouts against the dead west boxes before the retry. And then one note I wanted to bring up is that Nginx won't let you use the backup server flag together with the hash method. So this has to be done with the proxy intercept errors and an error page retry instead. And that's something that I noticed in my situation. But this is the part that I actually didn't expect here, which is the cache key bug. So regional routing creates a correctness problem routing alone wasn't able to fix when I tried to implement that. So while regions have separate edges, keying the cache on just the path looks fine, but they never share an edge. They never share an entry. But the cross-region fallback exists specifically to break that assumption. So the script swaps in a region blind key and sends both viewers at one edge. So the west viewer gets a hit on the east body though. So at 200 with the wrong content, no status code, no latency number, no cache header would ever tell you that. But putting the region in the key fixes it. So two entries, correct content each. It's what the very solves in the HTTP enforced right there at the edge. So as you can see in the takeaway, that's also mentioned down there. I want to go back to the diagram to tell you that 3 of the 4 stretch goals are in here. So there's 2 edges per region with consistent hashing inside each, the cross-region fallback rule, and region-specific content from the origin. But the fourth, which is comparing one global cache to separate regional caches, is essentially what that last experiment shows. And then there's one more gotcha that I just wanted to bring up, which is my max fail situation I had on the upstream. It kind of does almost nothing without a shared zone just because peer health is tracks per worker. So every worker rediscovers the outage just separately, and that one took me a while to figure out. But the repo link is in the ed post that is made, and the demo that you'll see on the GitHub repo will also replay everything just that you just saw, so you can see it on your own. So, thank you for your time, and I appreciate you.